Hello friends, in today's lecture I am going to teach a new topic, that is tree. In the previous lecture we had already seen that there are two types of data structure, that is a linear data structure and non-linear data structure. In linear data structure we had already seen that array, stack and queue. Now we are going to learn a new data structure, that is a non-linear data structure. There are two types of non-linear data structure. First one is a tree and another one is a graph. In today's lecture I am going to cover the topic of tree. So that tree is a non-linear data structure. Tree has a special data item called the root. For this concept we take an example. Look at this figure. Here some nodes you can see. Node A, B, C, D, E, F, G, H and I. Here the topmost node, that is A, is called as the root. Every tree has its root and the last level of that tree, that is called as the leaf. That node is also called as the terminal node, that is the end level of the tree. And the nodes between the roots and the leaf. Again I repeat, the nodes between the root and the leaf. The nodes are called as the intermediate node. Okay. Then now you all are understand what is the root, what is the intermediate node and what is the leaf. Okay. Now we move forward some important concept regarding the tree. The first one is the degree of a node. Now we are familiar with the node. Okay, now we are seeing that how we can calculate the degree of a node. The degree of node is nothing but the number of subtree of a node. Okay, the number of subtree of a node means, look at this figure. In this figure, A is a root. Now, what is the number of subtree of A? There are two subtree of A, that is B and C. This is called as a subtree, and again this is a subtree. That's why the degree of node A is a 2, because A has a 2 child, means 2 subtree are there. Now, in the similar way, the degree of node B is also a 2, because B has a 2 child, means the 2 subtrees are there. In the similar way, the node D, E and C don't have any child, means it don't have any nodes below that node. That's why the degree of C, D and E is a 0. Clear everyone? Now we will see the another concept, that is the degree of tree. In the previous concept we see that the degree of a node. Now we are going to see the degree of a tree. The degree of tree is the maximum degree of a node in a given tree. The degree of tree means the maximum degree of a node in a given tree. That means we have to first calculate the degree of every node. As we see in the previous concept, according to that concept, we are going to calculate the degree of every node in this figure. Now, the degree of node A is 2, because A has a 2 child, means A has a 2 subtrees. That's why the degree of A is a 2. Degree of B is a 1, because it has only 1 child. Degree of C is a 0, because it doesn't have any child. In the similar way, the degree of D is also a 0. Means in the whole tree the maximum degree is degree 2 because A has a degree 2, B has a degree 1, C and D has a degree 0. Means the maximum degree is equal to 2. So the degree of tree is a 2. Clear everyone? Now moving forward and see the another concept, terminal node. It is the very simple concept in which the tree having the node which has a degree 0, that node are called as the terminal node. We see in the previous figure the E, F, G, H and I, these nodes has a terminal nodes because the degree of that all nodes is a 0. That's why the node is called as the terminal node. Now the next concept is the sibling. The sibling is the children. Now we are moving forward the next concept towards the sibling. The sibling is the children node of a given parents. They are also called as the brother. Look at this figure. In this figure, node A, that is the root node, is called as the parent node, and the child node are B and C. Here B and C has the same parents. That's why B and C are the sibling, or they are also called as the brother. Now the next and the important topic is the level. The level, the tree has a different types of level. The topmost level on which roots are present, it's called as the level 1. And below that root, the nodes are present. That level is called as the level 2. And moving downwards, the next level is called as the level 3. And again moving downward, the next level is called as the level 4, and so on. Okay. In this concept, we must remember that the root is always on the level 0. Okay. Now we are going to the next and important concept, that is the binary tree. Look at this figure. In this figure, A is the root and A has the two children B and C. And B and C both have a two child, that is D and E and G and H respectively. Now below that, E has only one child F, H has a two child J and K, J has a one child L, and D, G, F, L and K have a no child. Okay, it means that in a binary tree, every node has maximum 2 childs are there and minimum 0 child is there. Means in the binary tree, every node has a child 0, 1 or 2, not more than 2. Okay, it's clear. Now take another example. Suppose consider node A and it has a 3 child B, C and D. Now it is not the binary tree because A has the 3 child, and according to the definition of binary tree, every node has a maximum 2 child are there. Okay. Now the next concept is the representation of a binary tree. We can store a binary tree in 2 ways. First, a static. It is also called as the array representation or a sequential representation. And another one is the dynamic or a linked representation. Now we first see the static array or sequential representation of a binary tree in the computer memory. Okay. Now first, in the first position of a tree, here tree is the name of the array in which we are going to store the binary tree. Now the first position of the array tree stores the root node. Okay. Now look at this figure. Here A is the root node. So A always stored in the first position of the array. Okay. Now according to the rule, the left child stores at the position 2 into k. And the right child stores at the position of 2 into k plus 1. It means that Look at this figure. I told you that A stores at the first position. Here is the array of 15 elements from 1 to 15. In the first position, I store the A here because A is the root and root is always stored in the first position. Now, according to the rule, the left child stores at the position of 2 into K. The left child of the A is the B, and B stores the position at the position 2 into K. That is 2 into the 1. K means here K is the position of its root and the B's parent is the A. That's why it's stored at the position of 2 into 1, that is second position. And the right child, that is C. C is the right child of the A. That's why C stores at the position of 2 into K plus 1. 2 into K means 2 into 1, that is 2. 2 plus 1, that is 3. The third position stores the C. In the similar way, D stored at the fourth position because the parent node of the D is the B and B stores at the second position. And D is the left child, so that we store at it 2 into K, that is 2 into 2, that is the fourth position. And E stores at the fifth position because 2 into 2 plus 1, that is the fifth position. And so on. Similarly, F stores at the sixth position, G stores at the seventh position, H stores at the ninth position, I stores at the 14 positions, and J stores at the 15th position respectively. I hope you understand these calculations. This is the static or array or sequential representation of a memory because the array elements are stored sequentially in the array. That's why it's called as the static array or sequential representation. Now, the next type of the representations is the dynamic or a linked representation. Okay, the dynamic or linked representation, we know the linked list. The linked list has a node and node consists of 3 parts. The first part, the main part of that node is the info part in which the original data of the tree is stored, and left and right parts is also there. Left pointer or left part is stores the location of the left child, and right part or right pointer stores the location of the right child. Take another example. Here A is the root node in which info part stores the A because this is the information in the root. Okay, now where the left part stored? Left part stored in the left pointer. Here is the tree A, B, C, D, E, and I. Okay, the left pointer is a B and the right pointer is the C. So B stores in the left part and C stores in the right part. Again, B is the info part, and again the left pointer stores the D and right pointer stores the E. In a similar way, C has only right pointer. That's why here is the null, and in the right part we store the I here. Okay, now what about the left and right part of the D, E and I respectively? As they are the terminal nodes, there is nothing in the left and right part, so we put the null value there. Now, the traversing of the tree. Here, the new concept is how to traverse the binary tree. Traverse means visit a node at least one. That is called as the traversing. There are 3 types of traversing. First one is the pre-order traversing, second one is the in-order traversing, and third one is the post-order traversing. In the pre-order traversing, first, as the name indicates, pre means first we visit the root node, then we visit the left subtree, and then we visit the right subtree. Clear? Then the in-order traversal, as the name indicates, in. First we visit the left and then root and then right. In means the root visited in between the left and right. Okay, the post order means the root visited the post, means after left and right. Clear? In pre-order, the sequence you should follow, that is root, left and right. In order, left, root and right. In post order, left, right and root. Take one example for understanding. Here, the tree you can see, the A, B, C. A is the parent node and B and C is the child node. According to the pre-order traversal, first we have to visit the root node, that is A, then left node, that is B, and then right node, that is C. Means the pre-order traversal of this tree is A, B and C. Now in-order traversal of the same tree is, first we visit the left, that is the B, then root, that is the A, and then the right subtree, that is the C. Means the in-order traversal is B, A, C. Now the post-order traversal of the similar tree is, first we have to visit the left subtree, right subtree and root. The left subtree means B, right subtree means C, and root means A, that is B, C, A. Now for the more understanding, we take another example of the traversing of a binary tree. This is the example in which a tree is given to you, and in the examination you can ask what is the traversal of this tree. You have to give pre-order, in-order and post-order traversal of the similar tree. Now, according to the rule given, you can solve this example. In the pre-order traversal, first you have to visit the node root, that is A, then A has a ke baad A, after A you have to visit the left subtree, that is this subtree is the left subtree and this subtree is the right subtree. Means you have to visit this first. While visiting the left subtree, again you have to do the repeated process, that is the first visit the root B and then left subtree, and this procedure is going on. After applying this repetitive algorithm to the node and the left and right subtree, we get this answer. You can solve it at home, and if you have any query, you can ask me anytime. My contact number is 7709045009. Okay, take care. Goodbye.